So hello from ChipEx 14 in Tel Aviv, Israel, the high-tech country. It's my pleasure to speak to a hot company and a hot partner, which is Imagination Technologies, and on a hot topic in addition. So I interview Mike Hopkins, which is a senior technology marketing specialist, and the hot topic is Wearable and IoT, Internet of Things.
Thank you. So what I'd like to do is just to introduce Imagination in terms of what we're doing in the wearable space, and also looking at components that build up the Internet of Things. So what you can see here is a range of wearable devices, and what we've actually found, these are actually based on MIPS processor architectures. What we've found is that MIPS is very, very good at sort of producing a very efficient system with very, very low power consumption. What you'll actually find is that each of these devices here is capable of not just telling the time, but also running a full Android operating system. So all of the MIPS processors are fully tied in with the Android build chain. So any applications that you can actually build for Android will run on a MIPS processor and can then be integrated into a wearable device. Now what we're finding at the moment is that the chip developments and the requirements for wearables are looking at lower and lower power. So what we're seeing are specific integrations of our IP cores to work on increasing the battery and power lifetime of a particular device. So we're seeing the move now from 3 or 4 days between recharge for a wearable device up to 30 days between recharging. And what we're seeing in terms of the architecture is an integration not just of our sort of chips that are fully capable of Android, but also sort of using some of our microcontroller technologies and integrating those into a single chip, and where the microcontrollers are used for sensor interfaces. So essentially you've got a fully integrated Android device with high performance and very low power consumption, but also the capability to integrate with a large number of peripheral devices. Now in terms of moving from there to the Internet of Things, we're seeing a lot of demand for MIPS in a lot of communications devices, so things like 3G dongles, 4G LTE modems as other examples, as well as networking devices. So what we then do is we have an IP block that allows you to add communications, and this is our Insigma radio processor core. So what you can do is you can actually take a MIPS controller and add that to an Insigma radio processor unit and create a connected device. What you will see in the far corner behind me potentially is some pure speakers. They actually integrate MIPS cores with our Insigma communications IP, and that allows you to have a single chip that's capable of not just doing Wi-Fi and Bluetooth, but also FM and DAB radio to create a consumer electronics device. Now from there you can then move on and build up many other devices. If you look at, say, medical devices where you've got a sensor, you've got a processor to process the signals, and then also a communications mechanism to talk to the outside world. So what we do to support the outside world communication is an internet service that we call Flow. So what Flow allows you to do is to build up different services with connected devices. So if you look at the Internet of Things, you need to have a processor core, a communications core, and also an internet service to allow those devices to communicate in the real world. So that's how we move from the developments in the wearables and then across into the Internet of Things based on MIPS processor architecture.
Looks absolutely fabulous. I think that IP provider with their imagination and their power of innovation will be the big player in the Internet of Things. So I wish you a great future.
Thank you very much.